Hello and welcome to Group 3. This is Michael, Robert, and Sam. We're going to be talking about analyzing telemetry to better anticipate problems and achieve our goals. Chapter 15. Okay, so what we're going to talk about is first we're going to talk about the use of means and standard deviation to detect potential problems. Then we'll do instrument and alert on undesired outcomes, problems that arise when our telemetry data has non-Gaussian distribution. And then we'll talk about auto-scaling capacity at Netflix, a case study. And then we'll talk about using anomaly detection techniques, and then talk about advanced anomaly detection case study. All right, so use of means and standard deviation to detect potential problems. First, what you do is you analyze production metrics by computing the means and standard deviation. What this does is this helps you to create filters to detect when your metrics are off and they're not really functioning within a normal parameter. Then what this allows you to do is configure alerts so that you can make corrective actions before things go too far or before you let too much time pass. What one of the things that it requires is you need a normal distribution of capture metrics to identify the mean. Then you would create what this will help you to do is create better alerts to capture these issues rather than waiting until after the problem is already passed. And then what it also does is it allows you to focus on different variances and outliers that are the most important. Sometimes data comes in and it doesn't look exactly right. When you have these metrics in place and when you have these alerts in place, you can focus on things that are really a problem because you have them lined up. Okay, instruments and alerts on undesired outcomes. What you would do is you'd first analyze the most severe incidents that you've had in the recent past, and then you would create a list of telemetry for earlier and faster detection problems. You use this telemetry information to confirm effective fixes and confirm the fixes are implemented. When you look for early warning detectors at different levels, so what you would do, first application would be you increase load times or slowing time as an example. Operating system could be something in an operating system could be low memory or low disk space. Database could be transactions taking longer than normal. On the network could be latency, bottlenecks, or inefficient resources. What you do is configure alerts to notify when warning indicators are observed that deviate sufficiently from the mean and take corrective actions. And then what you do is you repeat the process to fine-tune and discover failure signals earlier in the cycle, enabling quicker detection and correction. Some of the problems when you do this telemetry data, sometimes you don't have a normal bell curve for a standard deviation, and so one of the things that this does is it makes it kind of difficult to do things because sometimes what happens is you'll have alerts that happen that aren't really needed. They're in other words, you're over alerting. And then the other kind of component of that is from a statistical basis, properties of standard deviation don't actually apply when you don't have a bell curve. And the distribution is, when the distribution is skewed or spiked, it also makes it hard to detect these anomalies. So, example of Netflix, they had some scaling problems. What happened is they had delayed response to compute the need for capacity. In other words, they by the time they realized that they needed more capacity, it was often too late. And so the ASS decreased compute capacity following outages, causing issues for future incoming demand. And they also couldn't factor known data usage trends. So the solution that Netflix came with around the non-Gaussian distribution was scaling, Skyer scaling. what they did was they predicted the data use trends and then had an auto-scaling plan to meet it. All right, so using anomaly detection techniques, kind of like we talked about, what you do is you basically blend the operational components to and collaborate with statistical analysis. A lot of times the people that deal in statistics are going to be found in different departments, but what you ultimately want to do is use the statistic knowledge that your organization has and blend that with the people that are in charge of operations, and that's ultimately how you're going to want to put that all together. And then ultimately you use the statistical techniques to create these detection techniques in order to do that. One of those things that you would do is you'd use a process called smoothing. What that does is it uses rolling averages in order to detect anomalies or to basically manage workflow and operations. Okay, so what smoothing does ultimately is it allows you to avoid short-term fluctuations or short-term spikes. And it also helps you to focus on long-term trends. So you're not overproducing, underproducing in whatever manner that you're trying to detect. What this does is it helps to detect data when data or situations are outside of statistical norms. So what it does is it helps you to overcome some of the weaknesses of some of the statistical modeling that we've already talked about. Case study of this, Monitorama in 2014. Ultimately what they ran into was they noticed a period of time where the number of transactions per minute in their e-commerce site was dramatically dropping off and not returning. So they used a Kolmogorov-Smirnov test, which is just a fancy way of saying they used some statistical analysis to evaluate their data. So they found normal transaction levels didn't occur, a return on a particular day. They compared two probability distributions. What that does, so ultimately what it does is it compares seasonal and periodic data in order to come up with the norms that they should be experiencing to ultimately decide if those drop-offs actually were truly drop-offs that they were not experiencing normally. These types of analysis help detect potential problems before they happen. So rather than get worried about something because it's a seasonal drop-off or a periodic drop-off, it helps you do that. But if you ignore it and it ends up being a real problem, which is the case that they were finding, it's better to know where those seasonal and periodic data lie. All right, so in conclusion, you're going to want to create filters to analyze metrics and alert anomalies that exceed standard deviations, create meaningful telemetry data that users alerts desired outcomes for earlier problem detection, non-Gaussian distribution causes over-alerting and skews our telemetry. Lessons learned from Netflix, pattern predictability, Skyer, and overcome non-Gaussian problems. Use statistical calculations to notify your organization of potential problems before they affect production. And the biggest thing is learn how to say Kolmogorov-Smirnov, because it's much more impressive than saying that you want to do a statistical analysis. Questions? Here's our citations.